we'll be having 3 technical presentations. And this one also, we do not have any panel discussion. So we just wrap up once we had the presentations with a discussion session. So my pleasure to pass it on to Mamta, please.
Thank you, Victor. Thank you so much. And thanks for joining this session immediately after lunch. A bit difficult, but we'll try to make it interesting for all of you. Thanks so much. And I've been joined with my colleague, Dr. Hari Sudini, who will be co-chairing this session. And as the name says, the session is about the natural farming and regenerative agriculture with respect to the plant protection and soil microbiome. Probably this is what we are discussing from past 1.5 days, that soil health is the most important thing or is the backbone of the regenerative agriculture or the natural farming. So this is an important session and one of the major pillars when we are making a framework for the RA and the NF, what we are talking about here in this workshop. All of us knows, just to give a bit background, that how important the microorganisms are. Like microorganism, all of you know, it is a kind of a backbone for entire ecosystem. If there is no microbiome in the system, then I think there will be no agriculture. So that's how the importance of this session will be. And in this session, we have 3 presentations. And the presentations are around the biological options, which will talk about the quality issues with respect to the biological options, what we are practicing at the moment and what we are looking in the future as well. And then there will be a presentation by the second speaker who will talk about the opportunities and the constraints around these biological options. And then we will be having a perspective from the private sector around the bioproducts and some ideology around the next generation technologies, how we can link it with the natural farming and the regenerative agriculture. So each presentations will be around 20 minutes. So we have an advantage of 5 more minutes here with the speaker. We have 3 presentations since. And then 2 of the presentations are online and 1 presentation is here with us physically. So without taking much of a time, I think I'll invite the first speaker, Dr. Janardhan Singh. He is head of the Department of Organic and Natural Farming in the Himachal Pradesh Krishi Vishwavidyalaya, Palampur. And he will be talking about the biological options, including the microbiomes and the herbals for the crop protection, and also will be touching upon some quality issues and a few success stories, what has been done using these approaches in this area. So with this background, over to you, Dr. Janardhan Singh. You have 20 minutes and my co-chair will indicate the timelines for you.
Okay, thank you, madam. So good afternoon, everyone. First of all, I would like to extend my heartiest thanks to AgriSet and DST for giving me this opportunity. My topic is biological options for crop protection and quality issue under natural farming. So as madam told that since yesterday we are talking about the production and productivity beside the soil health and the carbon sequestration and the microbes. Okay. But as you know that plant protection, that is important components of any production systems. Okay. And as you know that in general, say 70% yield reduction is taking place due to the plant protection. If we have not adopted the control measures regarding this biotic agents, maybe insects, disease, and weeds, so automatically they are responsible for 20% of the yield reductions. Okay. So I am going to discuss the contents of in my lectures. First one, that is biological options, then quality issues. Then I will discuss about the limitations, and besides, there will be some success stories, and that is very important. Yeah. So first of all, I would like to tell the natural farming. As you know that this concept was first given by the Masanobu Fukuoka, and he was the Japanese farmer and philosopher. And he introduced his books, that is the 1-star evaluations in 1975. So he first time he mentioned about the nature of farming in his books. And as you know that in India, Subhas Palekarji, he gave the concepts of the nature of farming in the form of zero budget nature of farming, or we can say that is the Subhas Palekar nature of farming. So as you know that Himachal, yesterday one of our speaker told about this leading states. So Himachal is the third states after Andhra Pradesh and Gujarat, yeah, and more than 1.6 lakh farmers they have switched over from the chemical farming to the natural farmings. Okay, there are some initiatives in Himachal Pradesh. So it was started during 2016 with the 4-day workshops. After that, there is one establishment of the zero budget natural farming center. That is the unique centers which has been established in Himachal Pradesh in the CSK HPKV University. And that center is serving as a demonstration units, or we can say that is one of the mode for the technology dissemination of the nature of farmings for the farmers of Himachal Pradesh as well as the farmers of the adjoining states. So even there is one department. So first it was the organic department, organic agriculture. It was established in 2009, but later one, it has been renamed as the Department of Organic Agriculture and Nature of Farmings. And in Himachal Pradesh, as you know, there is Prakritik Kheti Khushal Kisan Yojana is theirs. And under this, we can say schemes, we are absolutely doing the research on the nature of farming, and center is there. This is our center where we are doing the research on the nature of farmings. Yeah, here we can say one components that is the livestock, or we can say we are talking about this local cow. Here we can say the black cow are theirs, okay, and they are local breeds. Yeah, so there is one components of the dairy components, and this is our farms. Here we can say that is the different bioformulations. Now the bioformulation, as you know that the biological crop protection products, also called the biologicals, and they represent a broad category of the plant protection products derived from the living organisms. So biologicals, yeah, there is question, are they a better option than chemicals? The short answer is yes, by almost every metric, including human health perspectives. So in the nature of farming, yeah, since yesterday also we got confused. Yeah, we are confused what is the nature of farming, what is the regenerative farming. Even we are using the zero budget nature of farming, Subhas Palekar nature of farming, Rishikeshi farmings, biodynamic farming there, Panchagabhya farming there. So automatically these are the parts of non-chemical farming. Here we are discussing about the non-chemical farmings. We are talking about the broad category of the farming. There are two: one is the chemical, another is the non-chemical farming. So here I am discussing about the non-chemical farmings, and nature of farming is one of them. Regarding the biological options, it includes the botanical or natural plants, bioformulation, crop residue and compost, and so on. So I am going to discuss those formulations really, yeah, actually we are using at their center, or we can say at their farm. So question is, why biological options for crop protections? So a number of reasons are there. First, as you know that most of the farmers, they are marginal small farmers, and they are around 86% of the total farmers. And having the land holding, it's we can say that it is less than 1.1 hectares. Even they are resource poor and cannot afford expensive inputs using the chemical crop protections. Regarding these biological options, as you know that it can be, these options, they can be prepared or produced on the farms. They are locally available and comparatively cheaper as compared to the options in the chemical farmings. They are known for their repellents and anti-fidants activity against insects. They have capability to cure the plant diseases. They are generally biodegradable, and they leave, we can say, no harmful residues. So these are the reasons, or we can say these are the merits of the biological options. Regarding this natural or regenerative farmings, as you know that they offer a solution to various problems. Since yesterday, we have been discussing about the problem. So these are the problems which includes that the food and nutritional insecurity, farmer distress, health problems due to pesticides and farmer residue in food and water, global warming, climate change, natural calamities, even poor soil organic carbon, soil health, even the deficiency of the micronutrients. So for all these problems, we can say natural farming is one of the options. So if you see some reaction, yeah, vegetable regions is theirs, why natural farming, some vegetable regions are theirs. Even more than 20% of food commodity samples are found less with the pesticide residues. It's very common in Himachal Pradesh, besides other states. Fertilizer usage enhanced from 23 to 54 kg per hectare. Apples receives 8 to 12 pesticides sprays. Cauliflower, capsicum, and tomato around 6 to 8 sprays. Pomegranate has gone to alarming up to 60 sprays. So there are some observation of the farmers. Okay, so more than 80% reported eye irritation is there. 77 to 81% fatigue is there. 66% farmers observe skin allergy. 59 to 77% reported headache. 41 to 56% reported vomitings. Even the interesting things is that 90% found a decline in the natural enemies and honeybees, which are very important, as we can say that is the pollinators. So biological crop protection market, if you see the market also, so there is growing markets of these biological options, yeah, growing at a cheaper, we can say faster rate than conventional crop protection due to increasing health awareness, environmental hazard concerns, sustainable crop production. And if you see the market, so global biological crop protection market expected to grow by 15% annually in this decades, we can say, whereas in case of the chemical crop protection market expected to grow by 4.5% annually. So if you compare, so the biological option, it is about, we can say that is the 3 times more as compared to the crop protection options. There is one news key how the exports of the biological, we can say the product is going on. Now the biological options for the crop protection. So there are 3 options. One is the botanical option is theirs. Another is the cow product-based bioformulations are there. And third one, that is the bioagent. So these are the 3 options. So in case of this botanicals, we can say it includes neem-based products. And generally, we can say they are being used for the control of aphids, soot borer, leaf miner, and sucking pests. Lantana extract is theirs, so that is used for the bean bugs, beetles, pod borer, and storage pests. Drake is there, extract, yeah, milia is there. So millibug and the mites, bean bugs, fruit fly, ghaniri, that is also being used for the control of aphids and other sucking pests. Eupatorium extract, that is used for sucking pest. Dustparni, that is the 10 leaves. Fruit borer, pea leaf miner, and soft-bodied insects. Agnesta is theirs, that is for the control of leaf miner, aphids, and mites. Ipomia extract, that is being used for the management of rodent pest. Brahmastra is there, sucking pest. Pod borer, fruit borer, from its name, Brahmastra, automatically when there is serious incidents of the insect pest, in that case, we can use the Brahmastra. Sostra is there, that is for the control of the blights as well as the leafy spots. Another option is that is the cow product-based bioformations, and especially that is being used in case of the natural farming, including the organic farmings. Okay, so Bijamrit, as you know, that is being used. Seeds are being treated with this Bijamrits, and main objective is that is to control the seed-borne diseases. Whereas in case of Jivamrita, yeah, it is being used for the control of the soil-borne disease. Fermented buttermilk is theirs, that is for the control of leafy spots, bugs, and beetles. Panchagabya is being used for the control of powdery mildew. Gram podboro is theirs. Tamarasi is theirs, that is for the control of leafy spots. And Ramban, that is being used for the blights and antibacterial and the antiviral. So Ramban, we can say that is the mixtures of the three parts of this fermented buttermilk and plus 1 liter or 1 part, we can say that is the cow urine, Jivamrita. Third option is that is the biocontrol agents. So these are the agents, biocontrol agents which are being used in the natural farmings, or we can say that is the organic farming. So trichoderma is there. You must be knowing it. They are very common. Bacillus is there. So these are the biocontrols. They are being used for the control of different pests. Now I will give some the preparation techniques and usage of the bioformulation, or we can say extract it there. So cow urine, that is one of the important components or option in case of the natural farmings, and that is being used as a repellent and anti-feedant to insect and the plant diseases. Okay, and this is first it is being diluted 10 times, and after that we can spray. Another is fermented buttermilk is there, that is also known as lassi there. So this bioformulation is being used against the powdery mildew and leaf spot disease of the plants. And even this is also used for the control of the soft-bodied insects, maybe aphid is there, mites is there, white fly is there. It protects the crop from the attack of wild animals also there. Another is Dracastra is there, that is being used against the sucking insects and the caterpillars. Another is Panchagabhya is there, that is used for against the soft body borer and the soil insects in agriculture crops. Then it synergizes the soil microflora and manages the variety of the plant diseases. Then Agnastra is there. Okay, these are the constituents of the Agnastra, and this is the important components in case of this natural farmings. Okay, so it protects the crops from the semi and fruit borer and leaf miners. Then Ghaniri is there. This is the another extra botanical that is being used for the very good management measure against aphid, pest, and organic conditions. Lantana extract is there, that is being used for the crop pest, significantly the defoliators. Neem extract is there, that is used after sieving and further diluting 10 to 20 times against a wide variety of the insect pest and diseases of the crops. Brahmastra is there. I just discussed in the previous slides, that is used for controlling the sucking pest, pod borer, and fruit borers. The spuddin is there, that is the extract of the 10 leaves, and that is going to protect the crops from the stem fruit borer, pod borer and leaf miners. And Ramban is there, so it helps in pod setting and protect the plant against disease of the crops. So these are some you can say preparation techniques, or we can say use of this bioformulations. Now the main bioformulation under the natural farmings. As you know that we are doing research on the natural farmings, okay? And you are knowing the pillars of this natural farming. These are the bioformulations which are being used under the natural farming. So first one, that is the Bijamrit, So as you know that these are the constituents of the Bijamrits, and farmers, they are easily preparing and they are using in the Himachal Pradesh beside other states also. So Bijamrit, as you know that is effective in protecting young roots from fungus as well as from the we can say from the seed-borne diseases. And add this Bijamrit to the seeds of any crops, coat them mixing by hand, and dry the seeds in the shade and use them for the sowing. Here we can say that is the samples of the Bijamrit, and these are the constituents. In case of the Jivamrit, as you know, it is being prepared with this, we can say water there, cow dung and urine we are using. Then 2 kg jaggery is there, 2 kg of pulse is there, and we can say that is the handful of the soil also from the burns, because the soil from the burns we are taking because it's full of the microbes. So it is going to multiply the microbes in the Jivamrit, and it is being used. It is a fermented microbial culture, and it provides nutrients, but most importantly, it acts as a catalytic agent that promotes the activity of microorganisms in the soil as well as increasing the earthworm activities. Okay, Jivamrit also help to prevent the fungal and bacterial plant diseases. Another is the solid form of the Ghana Jivamrit. Yeah, mulching there, as you know, that is important pillars because it is going to control the weeds also. If soil is covered with the mulch materials, automatically it will suppress the weeds. Besides providing the congenial environments for the microorganisms also, including the earthworm is also. Okay, you are knowing the different advantage of the mulch materials also. WAPSA is important. Okay, WAPSA means we have to maintain 50% air and 50% water. And that is one the technique, I think maybe we are missing this also, because we have to irrigate the root zone only. We have not to flood the whole fields. That's why we are preparing the raised beds, and between two beds there is channels, or we can say that is 9-inch channel. So we are irrigating the fields through the channels, not we are going to flood the whole fields, and that's why it is going to enhance the water use efficiency. Quality issue of the biological options. So quality, that is the important, that is short times. Yeah, quality sustained for very short times. For example, in Jivamrit, it is effective for 5 to 7 days. Bijamrit around 24 hours. Plant extract, bioformulation and bioagent 6 months. Biofertilizer 6 months. So there is comparisons from the chemical, we can say the options. Bioagents are very specific in nature, UV rays sensitive and less thermotolerance. These get washed away with rains and fast degradable natures. Biofertilizer, less thermotolerance and more over area specific strains. So these are the some quality issues. These are the some limitations, we can say. Very short shelf life is theirs. Sometimes they are the herbs, or we can say plants, they are seasonal, so automatically they are not available throughout the years. Bioagents like trichoderma and others, they are not easily available in the market. Sometimes maintenance of cultures of the bioagents, automatically it's need the hygienic and air conditioned environments is theirs. Okay. Management of insect pest disease with extract require frequent sprays. Huge manpower is required to manage the weeds. Yeah. Large quantity of biomass is required for preparation of the compost or mulching. And livestock, as you know, that is the important components of the natural farming, or we can say the any non-chemical farmings.
So you have 1 minute left.
Okay. So some success stories are there. Just I will quote it. That is the one of the farmer, Yasi Dolma, she is from the Laoli Spiti. And here we can say that is the she is doing the natural farming under 2.5 you can say that is the land area. And her expense is 30,000, and she got the 2 lakhs. Yeah. Another is Vijay Kumar, he is from the Kinnaur district. And here we can say there is a comparison between the conventional and the natural farming. So automatically here he getting the more income as compared to the natural farming. Salendra Sharma is there, he is from Solan. So automatically he is getting with the expenses 12,000 and getting the 12 lakhs from the 25 bigha, or we can say that is 1 hectare. No, sorry, not 1 hectare, we can say that is the 2 hectares. Another Satya Devi there, yeah, she is from the Simla, yeah. Again, she has just experiences toward the natural farming. Som Kishan is there, he is from the Mandi districts, yeah. Now, so these were some success stories. And these are the adoption of the natural farming, we can say more than 1.6 lakh farmers, they are doing this natural farmings. Even the more than 14,000 this apple grower, they are also switch over from the chemical to the natural farming.
Please conclude, sir.
Yeah. And Gram Panchayat, almost we can say whole Gram Panchayat, they are covered with this natural farming, 99%. Trend farming 1.7, more than 1.7 lakhs, and total training is. So this is all about this. Thank you very much.
Thank you, Dr. Singh, for highlighting some of the bioformulations and then few success stories. I think we are having few questions, but we will take up at the end of all the presentations. So over to the next question, Hari.
So the second presentation is from Dr. H.P. Babalard, Professor of Agronomy, University of Agricultural Sciences, Dharwad. The topic is opportunities and constraints of using various biological options in natural farming, regenerative agriculture. So can you please check is he online? Yeah, okay. Dr. Babalard, did you hear us? Dr. Babalard,
Can you see his name online?
Yes.
Yes.
muted, sir. You are muted, it seems.
ये कर सकते हैं. Gopal, can you? So we will call him.
Dr. Babalard, we are not hearing you.
So technology glitches, challenges with technology. Gopal, he's not picking up the phone. Okay, shall we announce then?
It seems it's talking.
Minutes ago, I talked to him. He said he is having viral fever. But he will try to talk.
But he seems to be online.
Okay, we will go to the next presentation. Dr. K.R.K. Reddy, who represents Sri Bioaesthetic Private Limited. The topic is next gen biotechnological and nanotechnological products for various farming regenerative agriculture. So Dr. K.R.K. Reddy is first generation entrepreneur in this particular area, especially biological inputs since 1990s. And over to you, Dr. Reddy.
Good afternoon, everyone. See, please, sharing option is given. Are able to see my screen?
Not yet, sir.
Not yet?
You want us to stay?
Just a second. That will be easy for me. One participant can show. No, you just give me the sharing option.
We have that. You have the access, sir.
Okay, is it okay? Are you able to see?
No.
Not
We
yet.
will share the screen.
Yeah, that's good. Yeah, please go ahead.
Yeah, we are sharing from our end.
Yeah, thank you so much. Can you make a full screen?
Yes, it is full screen mode now.
Oh, okay. Thank you, especially ICRSAT, for inviting me to talk on this current day topic. And go ahead, sir. Next slide. The topic is very broad, next-gen biotechnological and nanotechnological products for natural farming and regenerative agriculture. But I'm afraid to, of course, present but I can do one case study, and especially on the microbiome engineering. So move ahead, please. Yeah. See, now last 1.5 days, we are all discussing about regenerative agriculture, regenerative organic agriculture, regenerative biological agriculture, natural farming, everything. But today, what is the context? So why it is regenerative? That means recovering. So we are not, talking about starting the natural farming or starting regenerative, something like that. But here we are talking about the regeneration or recovering under whatever we lost from the nature, or the rectifications. So ever since our Green Revolution, in fact, actually helped us to have sufficient food for growing populations, followed by what happens, we all know, there's a lot of changes across the climate, our human health, and maybe what you call food, and as well as the environment. So all are now contaminated, and right now today, mankind is at crossroads. So on the one hand, we see both the sides, extremes, overweight, and the other side, the undernourished, and non-communicable diseases and the micronutrient deficiencies. Other side, the climate change and the soil degradations, whatnot. So how to feed the growing population without further degrading our natural resources? This is the context of regenerative agriculture, feeding growing populations without compromising on health, environment, and food security. So this is the context. So where the biological or biotechnological techniques, or maybe the nanotechniques, how they help. So next, please. And global demand, we all know we need to produce double by 2050. So without disturbing our natural resources, and also without disturbing our environment, and giving a safe, quality food to the populations. So is it possible at this rate? Difficult to achieve, but at the same time, there is a ray of hope, and we have the technological advancements. Now, my previous speaker spoke about a lot about the botanicals and also natural concoctions. So these are all working in the field. At what level, it is still to be assessed. But here, I will be presenting on how we can harness the natural resources, especially the microbial communities and the microbial diversity. Next, please. So the global trend at present, it may be a multinational companies, or the developed countries, or underdeveloped countries, or developing countries. The only one slogan everybody talks about is the reduction of chemical inputs. In each segment, we have the nutrition segment, disease control and insect pest control, weed control, abiotic stress tolerance, management, etc., etc. Every activity where we can replace the chemical components, at what extent. So therefore, the organics and biologicals are going to play a greater role. And as somebody mentioned just now, there is a 15 to 16% growth rate in biologicals and organics in agriculture across the globe. Next, please. So there is a global demand. Now we are talking about regenerative agriculture. I'm not much talking about natural farming. Natural farming is very well defined by so many scientists. So without using anything, if you can cultivate or you can produce something, there is a broader definition for that. So no inputs, or maybe no other things are used externally. So, but regenerative agriculture, it is having a great role in the world agriculture. So because we have left and right utilize all kinds of resources, and we have taken everything from the soils. It may be a good physical parameters or biological parameters, or maybe the nutrient status. Drained out everything, mined out everything. Therefore, we need to replenish. So rectify whatever all, and bringing back the biggest slogan everybody now talks about, bringing back life to the soil. That is the primary objective of the regenerative agriculture, especially when you use the biologicals. and restoring and rebuilding of soil organic matter. Everybody talks about this, and also soil biological properties, bringing back the biodiversity, improving carbon and water cycles. This apart, and incorporation of biological nutrient recyclings. That's what exactly the biological fortifications or nutrient recycling or soil regeneration, nitrogen fixation. These are all everyone talks about. Now we need to find out the practices and the solutions. It may be a kind of a service oriented, or maybe it's a input oriented. That is the what you call much needed task to be accomplished now. So biological crop protection methods, and also preserving the biodiversity, insect resistance management, and also the residue management. So these are the few things which are integrated, and then there is a possibility of what you call the regenerative agriculture. Next, please. So now the biological agriculture, that means most of the companies, even all multinational companies, if you see from the last 1 decade, you can see so many mergers and acquisitions are taking place across the globe. All the multinational, name any multinational company, now they wanted to start one biological division, or they are acquiring biological companies. All these days, all these years, I am into this business last 28 years. So only I have seen limelight for this biologicals only last couple of years, or maybe 1 decade. So where we can see a lot of interest generated across the multinational companies because of several reasons. The reasons which we have already discussed about the environment contaminations and the food contaminations and the health hazards of these chemical components. So therefore, there is companies or maybe the countries are withdrawing slowly the chemicals, and in place, they want to bring in some biological organics. So there is a pressure from the environment side, health and food security. That's why the people, even the scientists community, even farmers are also looking for a change, looking for a good input, and which can replace the chemicals. So therefore, now it is a broader defined environmentally responsive farming method through exploitation of beneficial microbes to increase crop yields. There, actually, I want to spend next 15 minutes how best we can utilize the multimicrobial strains which are naturally available in our ecosystem. Next, please. So coming to, of course, this already we have discussed, and these are the various components of biological agriculture, and where a reduction of chemicals at every stage of agricultural practices. It may be the nutrition or disease control or insect pest management or weed management. The possibly we can incorporate the various natural what we call components or biological components or organic components. End of the day, we need to restore the soil fertility. That is the basic thing what everyone is talking since yesterday. The soil is the base for agriculture. Next, please. So when you talk about this biotechnology and nanotechnology, I do not know how far it is going to be fruitful for incorporating nano products into organic agriculture or maybe regenerative agriculture. But today we have products and technologies available. So on shelf, the products are available. They mostly belongs to the biotechnological means, not the nanotechnological means, like the genetically modified organisms, their byproducts, and also the seed already it is there. And we have the two schools of thoughts, whether they're good or bad, GMOs. But today, some people consider, a lot of the nations are considered they are safe. So if you can take those measures, definitely we can use the genetically modified. We are using already tissue culture plants or the clones, etc., and biofertilizers, biopesticides. So therefore, the biotechnological means they have really proved very productive to use in regenerative agriculture. The nanotechnology, definitely only two kinds of products, biosensors and also the nanoparticles. So next, please. So I will be focusing mostly on one technology, which is highly adaptive, and also the basic technologies are available across the globe. And we have already 3 departments everywhere in every university or agricultural institute, like pathology, entomology, agricultural microbiology. So where the microbes are associated in all the 3 areas, So I'm talking about entomology means I refers to entomopathogenic microbes. So therefore, the microbiome engineering, the how best it can be utilized for regenerative agriculture. That is the context. Next 10 minutes. Next, please. So no plants lives in isolation. So not only the plants, every living creature, the microbes are ubiquitous in nature. They survive everywhere. They are there in the entire body, and humans considered only the 10% humans, 90% is microbial in terms of number of microbes what we have. So likewise, every plant or every animal almost is associated with a microbe. So the last decade, ever since omics has come to hand, so we are now thoroughly understanding the microbial diversities and the microbial functions and the microbial interactions with other living creatures. So therefore, harnessing these microbial technologies is going to be bring in paradigm shift in sustainable agriculture. So now that is another word apart from our organic agriculture or natural farming or regenerative agriculture. So understanding of soil microbiology, not only soil microbiology, maybe the microbes which are below the ground and above the ground, and that has increased leaps and bounds over the past 2 decades. The main reason is people started understanding the role of the microbes in life cycle of animal, plant, or whoever it may be. And at the same time, the technological tools are available. So biological software is available right now. And now we understand the microorganisms, their role in soil build up, and also the symbiotic their associations, and also they are endophytes, they are free living, they are associated. There are categories of microbes at every level of plant life cycle, they interact. Next, please. So as I mentioned, there are direct actions of these microbes, and there are indirect actions and also the interactions between the plant and the microbial communities. So these are all very much listed everywhere, and they're all there in our textbooks. Now practically you can make an organism to perform up to the satisfaction of a plant for its productivity. So we can have the consortiums, we can define the mode of actions and define what molecule, what enzyme, what organic acid involves in these reactions, interactions, and actions. Next, please. So therefore, we are now talking about the microbiome engineering, where you can exploit. Engineering is a word, means here we are referring to the assemblage of the microbes, the assemblage of diversified microbial communities as a formulation to modify what we call plants' rhizosphere or endosphere or philosphere. So therefore, we can define it as restructuring or re-engineering of the crop microbiome for improving and sustaining the nutrient supply within the soils. Maybe we can improve the nutrient use efficiency. We can mobilize the micronutrients from soil to the plant. We can assimilate. So likewise, a microbe can do hundreds and hundreds of functions. And every element has a microbe, or every microbe can do an elemental, what you call, assimilations. So microbial manipulations, especially rhizosphere or philosphere or endosphere, is a potential ecosystems in order to improve positive interactions within the plant. So this is the greatest discovery. It's all happening. Previously, we were only talking about the single microbe. Now the microbe to microbiomes. That means there is a holistic approach of the microbial communities to be exploited for the benefit of a plant, especially to withstand the abiotic stresses or biotic stresses or the nutrient components. So now the definition is the microbial communities, wherever they are associated with a plant or animal, collectively called as microbiome. So these microbiomes are now considered as second genome of the organisms. So as I mentioned, now the plant, if you take rhizosphere microbiomes are there, philosphere, endosphere, carposphere, that is seed microbiomes, wherever there is no space, what we call space in the plant where it is not conquered or occupied by the microbes, including the flower, including the pollen, the embryo. So where the seed pack their own microbes. And likewise, people also say, the scientists say that the plants recruit their own microbes. where we know the role of the plant exudates, they attract a community of microbial, and there is a strong association between them. At the same time, we have entomopathogens like entomopathogenic viruses, NPV viruses, Bt bacteria, and also we have like entomopathogenic fungi like Metarhizium, there are several other entomopathogens. So all these have an association with plant. So therefore, it is now we can exploit these microbial communities, either single or consortiums, to improve crop productivity. How? Please, next, please. So, okay, apart from this, the various crop habitats, but we can have these microbial, novel microbial communities from different ecological niches, like maybe terrestrial ecosystems, aquatic ecosystems, desert ecosystems. So like where you can always isolate, characterize the novel microbes, and you can make a bank. Suppose I am industry, I have my own functional microbial bank where I have thousands of microbes isolated from different climatic conditions, different rhizospheres grown in different crops of different agroclimatic regions. So there I have a bank, well-defined microbes. Now this manipulation of these microbes or engineering or assembling of these microbes is the matter. Next, please. And as I mentioned, we have now the microbes, and we have now, I think there is a regulatory system in place in India. So we have 3 Bs, biostimulants, biofertilizers, and biopesticides, all falls under a group called agriculturally important microbes, where they involve every function, carbon sequestration to control of the pests and diseases. And there's right side, if you see, the thanks to the omics platform, where it is now possible to understand how to culture and what the phenomic studies, genomic studies, metabolomic studies, and also the metagenomic studies is very, very critical and very important to understand the diversity of these microbes in a particular habitat or habitat. Next, please. So therefore, now coming to the functional verticals in agriculture, because I am from industry side where I will see, I look at the business opportunity. Well, for me, what the business opportunity is my business vertical. So where I can place these microbial communities for seed priming, soil amendment, and foliar applications. So right from improving the seed vigor, seedling growth, to make the plant tolerant to abiotic stress and biotic stress. And apart from that, the nutrition which I already mentioned today. So these are the business verticals, and where actually all these verticals or these the function should go hand to hand with farmers' package of practices. Then only these will be successful. Next, please. Yeah, this is the schematic representation, how we can make a new consortium based on the functions. So therefore, I mentioned one is the microbes which are originated from a particular crop. It's maybe rhizosphere or endosphere or maybe phyllosphere. So now we have targeted 20 important crops of the country grown in various agroclimatic regions, where we brought, including the stem, leaf, as well as the rhizosphere soil samples. We are isolating, we are trying to find out the relationship between the microbial communities that are the plant. So where very specific to the plant, where the exudates demand attraction of certain microbes associated with them. So from this functional microbial bank, and we go for the making a delivery system, and it can be a seed treatment one or foliar sprays, and how to integrate this microbial delivery system into the plant. So there are several methods of doing it, and soil inoculation, seed priming, and also now the injectables are there, especially for the tree crops and foliar applications. Finally, what we want to make is making a super microbiome with all the desirable characters, or the functional microbes, or essential microbes. You can go to any field and take the soil samples and understand, do we have the essential microbial communities in our soil? Today, we can assess that. And what is that diagnosis and also the prescription? Therefore, these products can be incorporated in the soil ecosystem. So therefore, we can make a super microbiome. And this is another case of non-GMO approach of trait development. That means you are improving a trait, or maybe incorporating a new trait like salt tolerance or drought tolerance. ICR is doing a tremendous work in this area. Next, please. Yeah, this is the schematic representation, how best we can convert these microbes, a single microbe or consortiums into a delivery system. Next, please. Next, please. Yeah, so therefore this microbiome optimization can reintegrate the beneficial microbes into agricultural system. So that means it will provide healthy food in a sustainable manner to the plant. And also it can impart the immunity to the plant, or maybe improve the innate immunity of the plant to withstand abiotic and biotic stresses. Therefore, instead of microbiome engineering, you can call also the microbiome optimization. Next, please.
2 minutes, sir.
Sure. So this is the holistic approach. So where the consortium-based approach is emerging as an alternative to the chemical agriculture and the GM crops. We are not talking about the GM crops. We are not talking about the chemical components. We are talking about the microbial communities, which are intimately associated with every crop plant, where you can definitely take these microbes from its rhizosphere, phyllosphere, endosphere, and can be used for soil health, seed health, and plant health to mitigate abiotic stress, biotic stress, and the nutritional. So this is the concept of holistic thing. So definitely the doors are open, and most of the big laboratories are spending money on developing new consortiums with very well-defined single microbes or microbial consortiums. Next. So this part is all about the technological advancements in the microbiome research and product development. Coming to the farmer's perspective, this is very critical. So adaptation to any new technique, it is very difficult unless until seeing is believing for the farmer. So reliance on new strategies and new technologies is a challenging one. There need to be effective demonstration of the benefits. That means cost benefit ratio, etc. And the crop response to the new product under the said agroecological circumstances. So other day we were discussing about nano products, whatever it may be, nano DAP or nano urea, nano zinc. So all these years we are giving. That means so the plant development is according to its nutritional factors and also the climatic conditions. So the plant adopted towards taking the nutrition from the soil to the rhizosphere. But today we are making plant forcibly to absorb the nutrients from the foliar. So it takes some time to accommodate that. So likewise, the crop response to any kind of a product is very critical, and the time and stage of application should be properly known to the farmer. So then the farmer will accept any change of product. Next, please. Maybe half a minute I need extra. Action, acceptance, and adaptation. That means this is all conversion of agriculture soils to more organic, preparing farmers to accept low productivity. This everyone is talking about. And the compensation of the losses. This we have written, what you call a paper also that was published in Agriculture Today, something like that. The compensation losses, then people will come forward and accept change. The mission mode project to be conducted under participatory approach and imparting knowledge and education about sustainable agriculture from the school onwards, encouraging bio-agri input industries, entrepreneurs. Finally, end of the day, a delivery system can be given by the industry only, not by the universities or research institutions. So the delivery system or a useful product should reach the farmer only through industrial scale. Promoting research and development, especially biologicals, and the government to support conversion process. This is a critical one. Kindly, all the scientists must note this point. The conversion process may be organic, chemical to organic, or zero budget farming, or natural farming, or regenerative. The conversion process we should be in a position to assure to the farming community. Next, please. And the role of input industries, I was mentioning about is, yes, the industry is ready always. And we have excellent entrepreneurship is there in the country. The startups are there, and definitely once they get some kind of an encouragement, industry is ready to deliver the goods. Next, please. And caution, yes, in the light of Sri Lanka disaster, our national policies on organic farming and zero budget farming are to be reviewed in the context of feeding our growing populations and their food security. Of course, absolutely no issue at all. We have an excellent 140 million hectares of the land and 130 crores of population. Young entrepreneurs are there and very hard working farming community we have. Definitely, absolutely. But only thing is little careful in introducing new technologies, new concepts. the success of any such initiative depends on the commitment of the stakeholders and their collective participation. That means the research scientists, farmers, industry, extension officers, so we all collectively can do it. Definitely, this is going to be a reality, regenerative agriculture. Thank you so much.
Yeah, thank you, Dr. Reddy. Yeah. So assuming that there is no next speaker because of ill health, so that's
I have joined. I have joined. Yes.
Oh,
Yeah, I think so. Hello, this is Dr. Bobla from US Dharwad.
So are you able to present now?
Yeah.
Oh, okay.
Shall I share?
So we heard that you are down with viral fever.
Yeah, that's what I have for
Okay.
last 2-3 days.
Oh.
Even then, I have interest to present.
Please make it brief, as brief as
Brief.
possible, 15 minutes.
Yeah, yes.
Thank you. Over to you. Yeah.
Okay. Thank you. What happened? It's okay. Am I audible?
Yes, you are audible, but
Thank
just keep it in sharing mode.
Same. Right. More. Okay. Okay. Respected Chairman, Co-Chair, and EDG Krishat, Dr. Kumar, and
Please keep
Gopal
it
Krishna.
presentation mode, sir. Presentation
Okay.
mode.
Presentation mode only it is. Sir,
Full screen, actually. It's
it is full screen only. Full screen only.
maybe you can unshare and share it again.
Okay, then. Stop sharing.
No problem, sir. In that case, you can please go ahead.
Okay. Okay. So, good afternoon to everyone of you. And this is the right time, that is the global level thinking about some of the potentialities, harnessing the potentialities of the natural farming and regenerative agriculture for sustaining the soil health or livelihood of the farm families. So actually the agriculture, that is resource, these two are very, very important. Always we talk about that. Economic Survey 2021 also said that even the resource scarcity and environmental externalities, so they play important role. And in that respect, it is the natural resources and environment play important role. And maintaining management of these, instituting some farming methods, that's mainly deals with regenerative agriculture or natural farming. So that play important role. It has achieved even last year, that is 19.9% the agricultural growth rate, and agriculture is the only sector that has recorded the positive growth rate. And this balance is tilting many times. That is, we have achieved the food production, and this food production is mainly through some of these crops. Actually, the major crops like irrigated crops like rice, wheat, maize. So the growth rate of these, that is mainly for the green solution technologies, we can say. And
So we are sharing your
is it
on.
okay?
Yes, please go ahead.
Yeah, okay. So many of the, it is the food security and other things that is they are playing important role. And many of these food security aspects, they are mainly concentrated on these few crops. But the main crops that are rainfed areas, even though we have irrigated resources, more than 60% area is under rainfed, and that will play important role in nutrition security and soil health management. And this is what we can see here. And
So please tell us on which slide you want.
okay.
We can share your slides on your behalf. Please say next slide, next slide. We will.
Yeah, okay. You have slides. I have
Yes,
shared
yes, we are
slides. I
updating.
have shared already said slides. I have shared. Yeah.
Dr. Babalat, can you see the presentation, what is being shared?
Yeah. Yeah. This is okay. You have shared fresh now.
Yes, we have made it full screen. And
Yeah,
can you
shall I
see
go
that,
back?
or you are seeing your own slide?
Yeah. Shall I go back?
No, you are on which slide?
So I am fourth slide.
Okay, this is about the Indian agriculture, the topic.
Yeah. The Indian agriculture.
Yes, so please say next, and then we will move it to the next slide.
Okay. Okay. Nice. Thank you. No.
Please continue, sir.
I think there is some challenge. We are not able to hear you. So should we go ahead, or if it is a challenge, then maybe we can stop it. Can you hear us?
Yeah, I'm hearing. Yeah, there's no problem. But I'm not audible to you.
No, no, no. I mean, now you are audible, but then in between there is a silence.
Okay.
Sir, we are sharing your slides just to say whenever
So
you.
full screen, you can make it full screen because it is
Yeah,
not visible.
we are sharing from our side the screens.
Full screen, you make it full screen.
It is already in
we-
full screen, sir. No problem. We change it from our side.
I think you can continue. We can see the slides.
Okay, okay, then fine.
We are on the land degradation in India, that slide. So
Yeah,
whenever you
yeah,
want to
fine.
move to next slide, you can just say we will operate.
Okay. You see, that is the recent available information that is about 51 that is measure share of this soil and water erosion that we see present day is more than 51%, or it is 51 million hectare, about 55.91, with all the efforts that we are doing for soil and water conservation and other practices. The land degradation is becoming more, and almost 55.91% land degradation is due to one factor alone, water erosion, that we'll see day to day, that is floods. This is major challenge now, and other factors are also there. That is next one, please. So the soil regeneration and regenerative agriculture, it is most important nowadays. So we have to concentrate mainly on the soil building practices and emphasis more on the increased crop and animal diversity, enhance natural process on the farm, and organic farming, and mainly the change in the farming systems and instituting some farming methods that is most reasonable, and we can manage these things. That too, in our university, we demonstrated over an area of more than about different research stations across the state, about 28 research stations, and even across the farmers field, more than 80,000 hectares. That is, soil regeneration is possible through organic farming and natural farming process, that is practices by managing them. The farm resources are better received for production purposes. That is what we recommend integrated farming systems. Next one, please. Then 6 strategies I put into these. That is the most important one. It may be regenerative agriculture, organic farming, conservation agriculture, then natural farming, then ecological agriculture, biological agriculture. People talk about that. So the minimum soil disturbance should be there. That is the main cause for degradation of the soil. So minimum soil disturbance, that should be protected. That is, it will help to protect the soil for the climatic variables. So we should concentrate on that and maximize the use of, minimize the use of chemical inputs, or you can divide of this also in some certain cases. If you say natural or organic farming with certification and other things, regenerative agriculture, conservation agriculture, we can integrate. Then keeping the soil covered, that is even cover crops we studied with the maize, cowpea, cover cropping, that is maximum area we can bring maize, cowpea under the cover crops. That can help to improve the productivity, and it will cover the soil and protect the soil. That is to a great extent. And next one, that is, so this natural farming, regenerative agriculture today, that is this topic, that is, I'm being an agronomist, that is for last 25 years, that is in organic farming and even natural farming. We have developed a certain organic farming package for 17 crops from Dharwad, US Dharwad. In 17 crops, we have the package without reduction in the yield. That I will come to few slides indicating the yield. So what we observed in this, that is the enhanced functional diversity, that is soil plant interactions, greater soil plant interactions we can observe under this natural farming, organic farming, regenerative agriculture. And this based on ecological principles, we can do better. Next, please. So, and this is what we developed this model, that is the process over an area of large areas. We are promoting Glycidia, and that is even I visited a Krishad, that is Rupella, and seen that is these practices. That is this is really wonderful for semi-arid tropics. That is, this is a very fast growing that is legume, that is shrub, that is woody perennial, and producing maximum biomass. That is, and it has a total sequestration capacity of around 4 to 5 gigatons of carbon dioxide per year. And this can help to pump the nutrients. It can help to protect the soil, and even during off season, actually, if we put it on the bunds on our contours in the field. So this certainly helps to protect the soil and hold the nutrients in the that is in the leaves, and when we bring it back to the soil, so it will recycle these nutrients to the soil surface. So, and it is having less adverse effect on the adjacent crop also, that we evaluated different crops like soybean, groundnut, and many crops. And next one, that is nothing, that is, there is it has no adverse effect because it is a straight deep rooting crop compared to Subapul. This is found to be the best what we observed in parts of this part of this country. Next. This is what we evaluated some of the technologies in organic farming. That is, some of the technologies mainly in organic and natural farming. That is, we have different strips of cropping and evaluated these strips of cropping, and this maize crop. Next one, and next this. And this is what the cover, that is what I emphasize, that is cover crop. And under irrigated situation, nowadays it has been created awareness among the farmers. They are maintaining the residues to improve its physical, biological, and chemical properties. So biological and physical condition is very important nowadays based on our experience, that is compared to the nutritional problems that we facing in that is. So this field is almost taking 8 to 10 ratoons of sugarcane and 8 to 10 years of whatever the rest, that is straw, that is sugarcane trash is being maintained, and different stages of the straw we can see here in the decomposition. And entire, that is water economy will be there. We observed, taken the observations, there will be water economy of almost 50% here, and the soil health, and there will be improvement, soil biota, there is a lot of improvement. Next one, please. And this is what the nutrient management in natural farming and regenerative agriculture. And this is where we have the measure, that is ecological principles. That is Kevin, he has explained that is very well in his one good article. That is how they plant, so that will be soil plant interactions, and how the nutrients are mobilized in the soil, and how these nutrients are made available to the plants by different process. That is very important, and they will be helping. That is they help. That is mostly that is in the improving the soil environment and the soil fertility. Next one. And this is another study, that is the characteristics of conventional approaches. That is the conventional and biological and ecological approaches that we have seen. That is mostly, that is the soil biota that play very, very important role. If you disturb the soil, provide enough biomass to the soil, then there will be naturally, there will be development of the that is the soil biota. That is, there will be a diversity of these microorganisms, different types of microorganisms, bacteria, fungi, actinomyces, even mycorrhizae. That is, they are all integrate, and they help in better nutrient mineralization, and even the nutrient mobilization also. This is most important that we observe. Next one is, and here some of the studies that we have done in Dharwad, in our regional research station, Vijaypur, that is for last 8 years on natural farming, and for last 15 years on organic farming. I'll just present some of these slides. That is in natural farming, that is, these are the components that we give more stress. That is Bisamrita for seed treatment, and Jeevamrita for foliar application. Jeevamrita is very good. It is Jeevamrita being practiced by many farmers now. We have a blanket recommendation of application of 1 ton of Jeevamrita. That is 1 ton of Jeevamrita.
Try to finish in 3 minutes, sir. Try to finish in 3 minutes, sir.
Okay, you please proceed. Yeah, thank you. Yeah. Then Jeevamrita, this you can skip Jeevamrita, these preparations, we analyze the contents, and if you have no time, that is, thank you. And the next, we have the Jeevamrita, that is the contents, and this is the farmer, and what we taken his success story. For last 10 years, he's practicing, and even climate vagaries. So he is a model for his entire village. That is, he is regularly preparing the Jeevamrita and applying it even during the excess rainfall or during the stress. It helps to protect his crop by improving the soil that is soil moisture content. So this is the advantage of the Jeevamrita, what we observe in addition to other organic manures. Next one. So Bisamrita next. So you can skip this Bisamrita, and mulching practices. Next one. So soil mulch, it helps to, and crop diversification we have done. Crop intensification is possible if you have a better soil moisture conditions, and if you improve the nutrient status. And what that we observed in our research, that is results. Even we found that soybean plus pigeon pea, cotton, groundnut intercropping systems with broad bed and furrow, then incorporation of the intercropping and incorporation of residues in situ. So you can increase that is next one. So it helps to improve the soil fertility and crop yields substantially. Next, please. And the crop rotations. Next, you know the advantage of crop rotations. Next, cover crops. This is the bottom, that is the green gram in pigeon pea. So pigeon pea area is almost, we have 1.2 lakh hectare in Gulbarga and district, or even in Vijaypur district is also next best highest either. So here, that is, if you think of already 80,000 hectares pigeon pea soybean area is there, that. So there the soil fertility status is really good in either district of Karnataka. That is how we now suggesting this intercropping systems would be the most popular one. And in maize, if you have in transitional tract of Harvard zone 8, region 4, that is we can all in there, that is it is really good. Next, this. And this is in cotton. We developed a complete package, Glycidia mulching, without any external inputs. We use that green residue mulch. And on this green Glycidia mulch in cotton, if you spray Jivamrita on this, so certainly you can see here that is different residues we have seen. That is, it has added much required nutrients, and it helps to because in natural farming, organic farming, weed management is the major problem that is farmers are facing. So such a mulching material, if it is grown on the bunds, and if it is a proper stage of one intercultivation, if you use it as a mulch, or even with, we tried even on the weeds, that is, if you put this mulch, the weeds are suppressed, and then you can use some of the Jivamrita or some of the other that is we can use. Next one, that is next one. So in sugarcane, already the farmers are practicing some of these systems. Next please. And some of the research studies, if you give 1 or 2 minutes, I'll just go through it. Please, you skip that is this year natural farming, conventional tillage, and then next one, conservation tillage, crop residue retention. Next one, please. So this has undergone, that is almost 8 years, that is in conservation tillage practices. Almost we got significantly higher yield conservation tillage with BVF as even with BVF and without BVF also works well in rainfed areas. So this is given the technology to the farmers of the state. Next one. Oh, next please. Next please. Next. So it may not take interest yield, that is seed yield. And we have the maize. We have evaluated in maize, pigeon pea, cotton, then rabi crops like the sorghum, chickpea, and other crops. And these are some of the natural farming, organic farming, conventional farming, and initiated during 2019-20 and about 2022. That are 3 years we have pulled this. Even you can see here the average productivity and chemical farming compared to chemical farming. This natural farming and organic farming, they are giving the higher yields, but it is giving similar productivity compared to the conventional farming. Because in Karnataka, we have a recommendation of conventional farming is chemical farming, whatever the recommended fertilizers, plus we apply the organic manures, recommended organic manures. So that is our recommendation, conventional farming. So overall conventional farming is given higher yield, but to get higher soil health benefits and other thing, that is we can have it. And coming to the premium price, next one, that is in soybean net returns, it is higher. Maize equivalent yields, you can have 1,51,000 under rainfed situations. It is almost, we want a maize alternate crops.
Sir,
So
try to complete, sir. Wrap up, sir.
Okay, sir. Next, under 2 minutes, sir. Yeah, you can
No,
say.
sir, within 1 minute.
Yeah,
please.
okay, sir, please. Thank you. Next, you can just skip these slides and I'll go on. I think that is, we have developed around 7, that is in natural farming also. We have the soil microbial analysis, and we have done isolation of beneficial microorganisms from different animals here and other local breeds. So this has also given that is why we have to use the local breeds. They have higher beneficial organisms. And if they are used as a rhizosphere or even the philosphere, their activity is better. Next one, please. Next. Okay. So soil enzymatic activity. So this is the information last other 2 slides. That is about 20 farmers, very, very progressive success stories have been prepared of these all 20 farmers and given to the submitted to the Ministry of Agriculture and Farmers Welfare Government of India. So we observed that is, you can see here, that is range of organic carbon, that is 6 to 11.75 in natural farming, and in conventional farming it has been observed from 4 to 6.4. So this indicated that even available nitrogen, there is a buildup of nitrogen. This because 10 years of product practices, this has been documented, and these samples we have in replications and from different fields analyzed and pooled. So this is a very good indication that.
Sorry, Dr. Babalad, I think.
Yeah, okay. Organic farming and natural farming practices, they certainly give. And this is a one success story, that is entire this hillock of around 16 hectares. That is Kamadenu village in Kalgati Taluk of Dharwad. That is, it was a barren, that is 2004-5. So then this has been rejuvenated and it has been improved to a great extent. Now people visit this site. That is, and they become laborers for other fields, but now they are engaging laborers. These 5 farmers were there in this. This is private land. So this is how that is required. And looking to this, there is an interdisciplinary research is needed that is going on. And we have developed the what previous speaker that is mentioned about the number of bio agents have been developed for maintenance of sucking test.
Thank you so much, Dr. Babalad.
Okay, thank you.
Yeah, I think we are running out of the time. So sorry about this.
With last slide, thanks, please.
Thank you so much. Thanks for your presentation.
So this is what the Mohandas Karamchand Gandhiji's nature cure implies that the treatment should be the cheapest and simplest one. And this is from the mind of Mahatma Gandhi. That is, so that should be, will promote such of the technologies. Yeah. Thank you.
Thank you so much. And we want you to stay online. Now, since we have a very less time left for the discussion, so maybe we can take it 10 minutes maximum, extended by 5 minutes from the tea time. And straight away, I think we will open it for the discussion. We heard 3 presentations in this theme around the plant protection and soil microbiome. So any suggestions, feedback, clarifications, the floor is open for the discussion. Yes.
I mean, this question was in general, I'll maybe direct it to Dr. Singh or others. Regarding the formulation of pest repellents especially, I mean, there are like a lot of varieties that are mentioned. And one feedback that is often is that it kind of increases the labor on farm if these are to be made on the farm every time. And or the availability of these locally where there is some guarantee regarding the efficacy, which is usually the case for these commercial pesticides. So in terms, especially when we talk about the convenience of farmers, what are, I mean, are there some challenges that you have faced or ways in which you have overcome this idea of how do you make available a certain reliable kind of portions and ensure the efficacy of these pest repellents? Yeah.
So generally, there is no parameter for measuring this efficacy, but these materials, they are being prepared with the local materials. Yeah, so automatically it will depend upon the raw materials and the type of the animals, we can say. Since we are preparing, suppose we are taking the cow dung or urine, so automatically that will depend upon the feeds of the animals and the breed of the animals. So as such, there is no standards for measuring this efficacy, or we can say the any type of standards like that. So as such, like in case of the organic farming, it is there. But in case of the natural farmings, there is no as such standards. Thank you. The problem is there. So as you know that I told na ki plant protections, if we are not able to control these measures, pest and as well as weeds, 20%, 75%, 70% loss is there. But in case of this biological options, very challenge. Yeah, to some extent, if viral infection is there or mild is there, then it is easy to control. But severe infection is there, incidence is there, so automatically there is problems. Thank you.
Sir, good afternoon. Sir, my question is for KRK Reddy sir. Sir, most of the biological and biopesticides which are thermolabile, they are less tolerant to the temperature. But under climate change scenario, nowadays, as day by day, year after year, temperature is rising. How these biopesticides will be going to work against the new pests?
Yeah, see, that was what do you call previously the people have thought of it, but now we have novel formulations. So where they can withstand up to 50 degrees temperature, and also shelf life can go beyond 2 years. So the new formulations like freeze-dried formulations or maybe spray-dried formulations, the previous is all talc-based or maybe the compost-based, but now the new technologies are there, new formulations are there. And because once we pass through the straight drying, the temperature goes up to 180 degrees. Of course, there is a flash drying, but whatever all the microbes or maybe the spores which are tolerant to the high temperature only survive. So therefore, there is a formulation methods available now.
Okay, sir. Thank you. Sir, one more question for Janardhan Singh, sir. Sir, you said that in Bijamrutam, apart from water and cow dung, cow urine, you said that we have to incorporate lime. What is the role of lime in Bijamrutam, sir?
So that is maybe linked with this pH. Yeah, pH is there. Okay.
It will induce the
So it will
stress
link with
mainly,
this
sir.
pH.
Induce the stress.
Yeah,
Stress management.
I am Dr. A.V. Ramanjanelu, working in PZACU. My question is to Dr. Bablat, sir. Sir, I would like to put forth one practical problem that we have faced during our experimentation organic farming. In Kharif season, we have taken up sweet corn. Immediately after harvesting, we have gone for groundnut. So in view of very less turnaround time, after incorporation of the sweet corn stubbles, so we have gone for groundnut sowing. So by the time we went and saw the field, the Spodoptera menace was very high, and it has attacked the germinating groundnut seedlings, and total crop is vanished. So to mitigate such kind of conditions, do you have any mechanism either under organic system or natural farming system, sir? So we are unable to hear you.
You are muted.
Depending upon the situation, we have to follow these farming methods. Actually, we followed many, that is certain period is required for their decomposition. And it depends upon how long we are in the field of that, field is under organic and natural farming. And what treatments we are used for the control of our decomposition of these straw. And because sweet corn actually is sweet, and there will be a problem. So usually we have the experiments on sweet corn. We use it for fodder, and just next crop we followed the chickpea crop. So such are groundnut, that is, you can think of that. You can remove such situations, and once in a year, 2 years, we have to think of incorporation of crop residues up to 8 to 10 tons. That is found enough in our field observations. There will be improvement in the physical condition and organic carbon content increased from 0.4 in our infrared areas to 0.75 for a period of around 8 to 10 years, I think. Yeah. So certainly that is, we have to use certain precautions depending upon the situation and experience. Farmers are the best judge, and also we should have that knowledge, and we should try it, evaluate it, and that's how this this will become future frontier area of research, that is natural farming and organic farming, and the funds and universities for national institutes. There is a need for support for research for these crops, because we evaluated number of biopesticides. So we found organic management practices, the beneficial microbiomes are more, and the pest disease complex is less compared to conventional farming or even chemical farming, exclusive chemical farming. So with that, we found that it is better, that is, it use these some of things looking to the situations.
Okay, sir. Thank you.
Yeah, maybe we are running out of time, but Dr. Janardhan Singh, I think the Himachal is one use case of natural farming, Andhra is another one. So you have done a lot of systematic research on natural farming. So have you also compared the total footprints of the natural farming versus integrated versus chemical versus organic? That's one. Two, have you also measured the soil microbial composition, not just bacteria, fungi, but deeper? What kind of microflora are developing there? And the third one is, have you done something on the quality of the produce quality analysis under natural farming versus the conventional agriculture?
Thank you, sir. Just I would like to share that we are comparing this natural farming with the organic farmings. Yeah, we are not comparing with the integrated farming or inorganic farmings, because earlier we were doing the research on the,
Sorry.
yeah.
So, but the issue is organic farming is not the problem. Problem is conventional, and you are not making any comparisons. So how can we convince people?
But as per the objective of the, we can say, state governments, yeah, because earlier, no, as per the objectives of the projects, we are comparing this organic and the natural farming. Yeah. And regarding this microbes, yeah, we are studying the impact of this natural farmings on the microbial activities along with the nutrient contents and quality aspects. To some extent, we are doing. No. Thank you.
Dr. Shailendra, you have a question?
You have time?
Yeah.
Okay,
Brief
just,
question, brief answer.
Yeah, brief question, answer up to him.
Okay.
So you and all Dr. Singh and also Dr. Bablar had presented a lot of work and a lot of formulations. I just wanted to know in terms of whether under control conditions you have quantified or measured the effectiveness, and you say that some severity there is not working. So have you identified certain trigger points? Whether farmers should wait up to what time, when not, whether under what condition it replaces the chemical pesticides, and under what condition it doesn't. So if those kind of things have already been done or still needs to be done, so that farmer get in confidence that, okay, up to this stage I can safely go with this line. If it is not working, then I go over this one, something like that.
We are doing this research under both conditions, as well as field and the protected cultivations. But just we are doing the research since we can say it is just for 3 years, okay? And just we got the extension, and we are going to validate this technology on the farmers' fields. So as such, result is there under both conditions, open field as well as polyhouse, but the same that is to be validated on the farmers' fields.
Madam, I would like to add to this. Yeah, I would like to add to this, if permits. So, Chairman, sir, that is in Karnataka, across 10 agroclimatic zones, for all the research stations, we have taken up these research studies, and we are concluding this year, because 4 years research data is required, comparative evaluation of natural and organic farming with conventional farming and bio-intensive natural farming and only chemical farming. These 5 practices on large scale they have been evaluated, and even in the farmers field, we are taking the farmers field benchmark survey and other productivity and their income data that is available now. And I can share some of the slides on this. The available detailed study has been done with respect to soil health aspects, productivity, and cost of cultivation, net returns, then pest disease complex, and their advantages and disadvantages and different farming situations.
I think so.
For the
We are
information.
running out of the time already. Late.
Okay. Okay.
Yeah. So I think thanks so much for all your questions, and I think we have exceeded the time. And just to conclude very briefly, I see like global demand for the biological options that seems to be increasing from all the presentations what we had. But there are still a lot of things to be addressed, and maybe something food for us to think about in future. How do we take it ahead, the technologies around the biological options to make it available to the farmers and really successful? Still, there is a challenge of the quality issues with the biological options what we have available with us. There are challenges with the scaling up. How do we scale it up and to the farming level, and how do we make it as a success case, having a cost benefit ratio in mind? And for example, we heard about the several bioformulations, but then how do we make it useful at the larger level on having a pan-India initiative kind of thing? That still seems to be very challenging at the moment. And as we move ahead towards the microbial engineering, still I think we should keep in mind that how do we keep intact the ecosystem microbial community. So these are some of the questions which are still to be answered, and probably the scientific fraternity can answer those through the research and R&D. So that is very much needed in all these areas. So with this, I think we have to close this session, and I would like to thank Dr. Harisudini Kochar and the rapporteurs, Dr. Gopal Krishnan and Dr. Jaba Jagdish, and all the participants and discussions and all the speakers. Thank you so much. Thanks.
Thank you very much, Mamta and Hari, and also all the speakers and the rapporteurs. So I think we will now go for a health break. If we can be back and get seated exactly by 3 o'clock, then we can start the 7th session. And as you know, after that, we also have a special